Hello there, and then welcome to a brand new video. This is How Beyond Numbers, where we learn maths the easy way. In this video, we are looking at equality of vectors. If you've not checked out the playlist on vectors, you can do that in the description section. Now, when we talk of vectors being equal, then we simply mean their corresponding components are equal. You see, so let's take a position vector A, whose coordinate is x, y. Or let's make it x1, y1. And then let's take a position vector B whose coordinates would be x2, y2. Now, if you want to say that position vector A is equal to what position vector B, then what that means is position vector A's components were what? x1, y1. Then it simply means that it is equal to that of B, which is x2, y2. You see, and that is just it. Now, another way we can know that two vectors are equal is when their magnitudes are the same. So let's look at what I have here on the graph sheet. You see, so this graph represents what? Vector AB, from this vector A all the way to B. And this over here is vector CD. You see, now if we were to find their magnitude and compare it to each other, see, if I put it here, it fits perfectly. Their magnitude fits perfectly. We can also say two vectors are equal if their magnitude are the same. So in view of this, let's look at how we apply this concept to solve problems. So applying the concept, look at this question here. It says a delivery robot moves from a warehouse, and this is the coordinate of the warehouse, so W22, to a house H56. Another robot starts at K01 and ends at L, which is 35. Are the journeys equal? Now, if they are or not, what does it mean for their fuel usage? So let's try and then see if we can write out something that will help us solve this question. Our solution. So for robot 1, let's just call it robot 1. It starts at what? W, which is 2, 2, and then ends at what? H, which is 5, 6. You see? So if you want to find the vector WH, then it's going to be what? The position vector of W, the position vector of H minus W. And H minus W simply means we have 5, 6, minus W, which is 2, 2. Evaluating further, we have 5 minus 2 and 6 minus 2. And that gives us a what? A 3, 4. So this here is the vector WH. Now we have the path or the vector for the first robot's movement. Let's look at robot 2. So robot 2 started at what? K, whose coordinate is 0, 1, and then L, whose coordinate is 3, 5. Okay, so if we want our K, L, then it's going to be position vector L minus position vector K. And L was given as 3, 5, and then K, we have what? Minus 0, 1. So evaluating further, we have 3 minus 0, then 5 minus 1, giving us a 3, then what? 4. Now, if we look at the two values we've solved for, that is W, H, and that of K, L. This is 3, 4, and this is also 3, 4. So it literally means they are the same. You see? So yes, their journeys are what? Equal. That will be the conclusion over here. What then does it mean for their fuel usage? If the distance we are covering or our vectors are the same, then it simply means we are going to use the same fuel. You see, so a knowledge of this can even help you to determine your fuel usage or what have you, your spendings and everything. That is a practical application of what? Vectors. There are other applications that you also need a little bit of algebra. Let's look at how to approach those. Okay, so in view of that, this is the question we have here. It says, given vector AB, which has coordinates x minus 3, then 2, and CD, whose coordinates are 5, to find x if AB is equal to CD. So how do we go about this? This one involves a little bit of algebra. So we know that AB is equal to CD. And what does this mean? So vector AB here is equal to vector CD. That is equal vectors. We know vector AB was given as x minus 3, 2. So x minus 3, then 2 is equal to our CD. This over here, 5, 2. All right. So with that said, we said vectors are said to be equal if corresponding components are the same. What that means is if these two vectors are really equal, then this component here is equal to this one here, right? And forming an equation out of that, we have x minus 3 being equal to 5. That is for the x component, all right? So for x component, we can now solve for what? The x. Making x the subject, we have x is equal to 5, then plus your 3, and your x then is equal to what? 8. As simple as that. For what you have here, it already says 2 is equal to 2. There is no variable to solve there. You see? So therefore, our x is equal to 8, and that is it. All we are trying to do here is to apply the concept of what? Equality of vectors. Let's solve one question, one very last question, then that'll be it. Okay, so for this last question here, it says if PQ is what? 4x, 2y, and RS is 6, 4. Find the value of y if RS is equal to PQ. Now this here, you realize that there are variables on both the x and then the y coordinates. So our solution. Now you can choose to pause and then try it out on your own to see if you would get an answer. Now we know RS is equal to what? PQ. This equation here. So we know our RS is what we have here as 6, 4. So it implies that 6, 4, which is for RS, is equal to PQ. And PQ is 4x, 2y. So with that said, vectors are said to be equal if the corresponding components here, we mean x is equal to x component is equal to x component, and then y component is also equal to y component. You see, so with that said, we come and then say for x component. So for the x component, we know we have 6. So 6 is equal to 4x. And now you'd have to make x the subject. And how do we do that? We divide both sides by 4. And with that, this 4 here takes out this 4, and we are left with what? 2 dividing 4 how many times? Twice, and it divides 6 thrice. So we can then say our x, the x we are looking for, is actually equal to what? 3 over 2, or you can just say 1.5. That is it for the x. Then we come to the y component. So for the y component, we can also say that what? 4 is equal to 2y. Those are the components of y. So 4 is equal to 2y. And what do? We would have to make y the subject by dividing both sides by 2. So that this 2 here takes out this 2, and then 4 over 2 gives you a 2. So it implies our y is equal to 2. And with that, you are done solving. So you can say, therefore, x equals 3 over 2, and then y equals 2. As simple as that. So basically, this is how we apply what? Equal vectors. And as we have said, vectors are said to be equal if corresponding components are what? Equal. We started by drawing some vectors here, and I've showed you that their magnitudes can also be equal for you to determine that what? They are equal. Now, as usual, I'll leave you with some exercises so that you try your hands on, just to test your understanding. So here are the questions. They are just about 5. You can try your hands on them. If there's any point where you doubt any of your answers, you can always come back and then check the examples we have solved, or let me know in the comment section, and then I'll address that for you. Let's have beyond numbers, and if this is your first time on this channel, you can always choose to subscribe so that anytime I release any content, you'd be notified as well. Thanks for watching, and I hope you've learned a lot. See you in our next session. Bye for now.